All right, so good morning, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. So if you're joining us for the first time, and I know some of the students are today, we are all about bringing conservation, adventure, and science into classrooms around the world. And today is exciting for a number of reasons. First of all, our entire theme for the month of September is ocean plastics. It's a topic that we've covered for years, all September long. I think we have 15 presentations in the month about it, but this is our first. So we're really excited to dive in with that, highlight one of the most important topical issues of our time. And secondly, this is our first high school session. So we've always broadcast to all ages, but this year we're having special programs with people that are going to talk more specifically about their career and the path that led them to where they are today. So we're really looking forward to sort of intense, more detailed questions. So whatever you guys can share with us when we dive in with Q&A, we'd love to hear it. So without further ado, we are joined live by Martina Capriotti. So she has joined us before. She's one of our favorite speakers, and her personal experience with scuba diving and exploring the coast in the Adriatic when she was a girl led to this incredible career today where she gets to work on, again, solving one of the world's great modern challenges. So I'm so excited to bring her in. Martina, thank you so much for joining us today. And
hi, guys. Hi, guys.
Can't wait to dive in with your presentation. So take us away.
Perfect.
All right.
Great, guys. So happy to be with you this morning. My name is Martina Capriotti. I'm a marine biologist and a National Geographic explorer. I'm currently working in USA as a researcher, and today we are going to talk about microplastic pollution. But before starting to talk about microplastics, let's see how I get to this point. So I'm originally from Italy. I was born and grew up in a little town called San Benedetto del Tronto. It is really, really nice. So if you travel to Italy, please stop by there. So as you can imagine, since I was really, really young, I had a really special affection for the sea. I started to swim when I was really young. And when I was a teenager, I became a lifeguard, and I also became a scuba diver. And when I start to explore the beauty of the underwater world, I basically fell in love with the marine environment. So I decided to study marine biology, and I was so lucky because I'm actually doing a really wonderful job that allow me to work in the field, do work in the lab. That is also really, really interesting. During my career, I worked underwater, in surface seawater. I also worked with many animals, and I had a really broad kind of experience. I master's degree in Italy, in Marche region. I also had an experience. It is called the Erasmus project. Is a project supported by the European Union for the travels abroad. And so I was in Norway at the Norwegian University of Science and Technology to study a really interesting topic, so endocrine disruptors. We're going to talk about that later, but just keep that in mind. Then I had my PhD at University of Connecticut, not so far from I was born and grew up, basically. Then I want absolutely to study microplastic pollution and its connection with the chemical pollution. So I wrote a project and applied that to National Geographic, and I was so lucky to be granted by the National Geographic Society and also from Sky and Shore Rescue, that is the campaign to protect our ocean from plastic pollution. Launched by Sky, that is the major media company in Europe. Now I'm working at University of Connecticut. I'm actually working on 4 species of suspension feeders. So basically, suspension feeders are marine animals that feed filtering seawater. The specific, I'm working on 2 mussels and 2 sea squirts. So yeah, that's my story. I'm actually now presenting from Connecticut. I'm still working here as a researcher. So today we're going to talk about a really particular aspect of plastic pollution. You know, plastic pollution is a really, how can I say, it's really sad. It's provoking really severe damages to marine life. There are many animals that are entangled by plastic or also fishing nets. Many animals ingest huge quantities of plastic objects. For example, on the left, you can see a cetacean found along the Norwegian coasts, and University of Bergen scientists found a lot of garbage inside the stomach intestine. Found like more than 30 plastic bags, found more than 70 plastic caps, found flip-flops, but a huge amount of garbage. So these, what we can see from these sad pictures, it's actually visible, okay? But in the ocean, we have another threat that unfortunately is invisible to our eyes, but is really much more present. And I'm talking about microplastics. So when we talk about microplastics, we refer to plastic particles smaller than 5 millimeters. So they are really, really tiny. This means that only the big particles can actually be seen with our eyes. The smaller one can be seen only at the microscope because they are really invisible. But where do they come from? Microplastic can be classified mainly in primary and secondary microplastics. So primary microplastics are plastic particles that are intentionally produced of these dimensions so small. For example, they are incorporated in abrasive pastes, in toothpaste, in facial scrubs, and everything ends up to the ocean when they are released in the sink. Secondary microplastics become so small in a second moment, basically, after the degradation process of bigger plastic objects. For example, let's think about a plastic bottle that ends up to the sea, and after many months and years that is subjected to the force of the ocean, to the UV sunlight, the materials start to become weaker and weaker and to fragmentate in thousands of these little pieces. We also have another category of microplastics called microfibers. Basically, they are really tiny filaments that come from basically from the synthetic fabric. Okay, so every time we wash our synthetic fabric clothes in the washing machine, we are releasing literally thousands of these microfibers in the environment. And unfortunately, there are really few plants on the planet that are able to stop the fibers. So yeah, maybe we can talk about that later in the QA question, but yeah, this is a really serious problem. Where can we find microplastic in the environment? So we can find them everywhere. We can find them in the surface seawater. We can find them in the water column. We can find them also in the seabed. And the most important, we can find them inside animals. Indeed, one of the main threats of microplastic pollution is the ingestion. That can be ingested not only from the bigger, larger animals, but also from the really tiny, smaller one, like plankton. Okay, and plankton is a category of animals that are at the base of the food chain in the sea. So basically, all this amount of microplastics are able to be transferred at each level of the food chain, arriving at the end also to humans, because you know that humans, unfortunately, are at the end, at the top, sorry, of almost all the food web on the planet. Indeed, we have evidences actually that humans eat microplastics every week. One really interesting aspect about microplastics, it is really interesting, not only because I studied that in my project, but also because it's a really particular feature, is the ability of microplastics to attract on their surface a lot of chemical contaminants. So when we talk about chemical contaminants, we talk about molecules that unfortunately are toxic for life, and they are released into the environment. Let's think about hydrocarbons. You probably already heard about pesticides that are widely used in agriculture, but we also have phthalates that are some additives that are used in plastic production, for example, or parabens or flame retardants. So these are only few category of chemicals that can be found in the sea and can be found on the surface of microplastics. So basically what can potentially happen is that when microplastics is ingested by marine animals, they can carry all these contaminants, all these chemicals with them. Many marine organisms already accumulate these toxicants in their tissue through the food, through the respiration, and so microplastics can potentially be an additional source of these contaminants. But what's wrong with these chemical contaminants? So among all the dangerous action that they can provoke, basically, there is the endocrine disruptions. So I know that it seems a really bad word, but it's not. So the endocrine disruptors are some molecules, so some substances that are able to mimic our hormones. Okay, if you can see on the in the slide, I put two chemical structures of an endogenous hormone, so a real hormone, a natural hormone, and a contaminant. You can see that they have a really, really similar chemical structure. So it means that the contaminant, when enter a body, not only human body, but also a lot of marine animal body, can act on behalf of this hormone, creating a lot of problems, a lot of hormonal dysfunctions. Indeed, that's why I love to call endocrine disruptors are molecular impostors, because they actually act on behalf of the hormones. So how did I study all of these? I promised Jess and Joe to talk about my field experience and my job. So let's find out how I studied these aspects of microplastic pollution. So first of all, there is before starting a project, there is a huge part of planning, decided sampling sites in the sea. In that moment, I was working in Italy, and I decided to focus my studies on Adriatic Sea, not only because I was born there and I grew up there, but also because it is a particularly vulnerable area for contamination. So, Adriatic Sea is this area, and in the specific, I was studying in this part of coastal waters. Then, so after the planning, we basically start the sampling campaign. Sampling campaign means that we go to the sea and take samples. Let's go. This was our boat that we used for sampling in the different points. We had specific sampling points, so specific areas where we decided to take our microplastic samples, and we found this area. We found basically these areas thanks to a GPS. And once arrived in the sampling point, we basically start to do briefing, organize the job. Really, really important when you are in the field is to label everything, to take notes, to keep track of everything you do, and also make comment on how the sampling is going. Then we build up the sampling instrument. This is a microplastic net manta. It is a real net that we use not for collecting fish, of course, but for collecting and catching microplastics. So when it was ready and built up, we release the microplastic net manta in the sea, and we can see how in this moment it is collecting microplastics. I already told you that microplastics are invisible to our eyes, so that's why we can't see that, but they are really there. And if you can see that little propeller, that little screw inside the mouth of the sampling net, it is really, really useful to calculate the amount of water that enter inside the mouth. And we need this data because then we can compare the amount of microplastics collected to the amount of water that enter in the instrument, enter in the device. So you can see here the microplastic net manta from another angulation. I actually want to publicly thank the Italian Federation of Aquatic Rescue that provide us a really strong support in our field campaign. And look for 1 second at this angulation, at this perspective. So basically, water enter in it and pass through this net, and microplastics are accumulated at the end. So in this area, in this sort of cap, let's call a net cap, accumulated at the end. So this device was troll for 20 minutes in each sampling site. So after 20 minutes, we wanted to collect all these microplastics accumulated inside this cup. And we also want that all the microplastics that remain in the net are actually, that actually ends up to the final cup. Then we moved all our samples in a sieve to be washed and to be actually sieve. Of course, you can see not only microplastics are collected, but also a lot of natural material Okay, then we moved, we store our sample in a really clean container, and we label this container with the name of the sampling station. And this is really important because so we know that that sample, that microplastics are collected from that specific sampling site. During I love to work in the field because during the sampling you can make wonderful encounters like dolphins and also amazing jellyfish. And when the sampling day is finished, we generally come back to the harbor. What you can see here is the San Benedetto del Tronto harbor, and but this is the end only of the sampling campaign. A lot of the work then is done in the lab, where we moved our samples, and we pass a long time every day, all the day, to analyze every single piece of microplastics. So basically, I measure them, I took photos to them with the microscope, and I also weighted all the samples with a really accurate balance, an analytical balance. And after that, another important step of my job, of my work in this project, was to examine the amount of chemical contaminants on the surface of microplastics. As I told you before, microplastics are able to attract on their surface a great amount of chemical contaminants from the environment. So I wanted to know which kind of contaminants can be actually found on their surface. So I used a special solvent and a special tool. I think that you love it. It is a sort of shaker. And it is actually called the vortex that shake the samples really fast. Then with this solvent detached all the chemicals from the surface of microplastics. So basically what I had at the end is a sort of, I love to call that cocktail of contaminants. So a mixture of all the contaminants found in our samples. After that, my aim was to see which kind of chemical categories are in this cocktail of contaminants. And unfortunately, we found pesticides, we found hydrocarbon, polycyclic aromatic hydrocarbons, we found polychlorinated biphenyls. It is also a really bad word, and also really bad toxicants. And in addition to that, my aim was to analyze the biological effect of this mixture. What does it mean? I wanted to know which kind of effects this mixture of contaminants was able to provoke. So I already mentioned the endocrine disruptors that I called molecular imposters. And unfortunately, I found that this cocktail of contaminants was able to act as endocrine disruptors. So there are some substances inside that could mimic endogenous hormones. And at this point, I don't want to enter into it too much, but yes. We found contaminants associated to microplastics. But the life of a researcher doesn't finish with these, and doesn't finish with the analysis of results. Another really important part of our life is to spread our results to scientists, so to colleagues, but also to other people that are not science related. So how do we do that? So we basically collect all these results. We want to make, I'm going to say, arrange them to provide a sense and a meaning to what we found, and write an article that is published. And yeah, so I'm also really happy because my paper was accepted just a few days ago. So yeah, we basically are celebrating together. Yeah, so I don't want to go over. I hope you enjoy this presentation, and I really hope that you like the life of a researcher and a marine researcher, because it is really, really cool. If you want to follow me, I'm on Twitter, I'm on Instagram, but if you have specific question, we probably have time to talk about that now. Is that correct, Jess? Great, thank you so much.
Yeah, that's perfect. That was fantastic, Martina. Thank you so much. So if you want to get rid of your screen share so we can see you, have a bit of a conversation, we'd love that. For anyone joining on YouTube and Facebook, we have full classes on YouTube. We have a group in Argentina joining us on Facebook. That's really exciting. So all over the world, if you're tuning in and you have questions, let me know in the chat bar, YouTube, Facebook. I'll get it and share with Martina. For Miss Devon's class too, you can start typing questions in the chat as well. And Miss Ryan's class, we will come to you guys in just a second. But I wanted to kick off. I mean, first of all, you have the coolest office of all time. You get to go out on the Italian coast to go look for microplastic. That is a great place to work. Lucky you. Is there a favorite part of your job? Is there something that you wake up every morning and you're just thrilled to be able to do when you get a chance to do it?
Of course. Yeah, I love working in the field, in the sea. And now, for example, I'm working in Connecticut, and really lucky to work also underwater. So yeah.
Nice, fantastic. All right, I'm going to head to Miss Ryan's group. Miss Ryan's class, if you guys have a question for us, great. If you don't right now, that's totally fine. We can come back in a minute, but go for it.
Hi, I can't put my camera on everyone. Can you see me though?
Yeah.
Oh, yeah, we can see you.
One question I had is how you're funded, Martina.
Yeah, so depends from the project, basically. For the project that I just presented, it was funded by a grant that I got from the National Geographic Society and from a scholarship of the Sky Ocean Rescue Campaign. Because like I said at the beginning of my presentation, I wrote this project because my intention was to understand the relationship between microplastics and chemical contaminants in the environment. So I wrote this project, I applied for a National Geographic grant, and so for that specific project I had these two support. But then it depends from the project, because for example, I'm currently working US, and here I'm funded from another agency. So yeah.
Yeah, I love whenever we have high school classes in. It's always the first question is how these things get funded. And I mean, it's a good question, whether it's science like this or, putting rovers on other planets. I mean, this is expensive stuff, but it represents such a small portion of all the budget of what, things go into in Canada and the US and around the world. I think all of the science budget in the States is something like 1.5% of all the budget. And that's all the exploration, all the discovery, all the things like this that contribute to making the world a better place. So great question, guys.
Yeah. It actually, also can be different from country to countries, because also the first of all, the amount of money and also the possibilities. You should know that there is also a lot of volunteering in research.
There's a lot of volunteering research.
Sometimes, because for example, when you want to write a project, you have an idea and you want to start a new research project. You may want to, how can I say, to find out more about what you are applying for. So in that case, it's all volunteer.
Yeah. Yeah. There's a lot of passion projects in science, but it can lead to really, really cool careers if you stick with it. So that's something that we like to highlight here. Miss Devon's class joining us in St. Thomas, they want to know, what's the furthest you've found plastics from their origin? So have you found like Canadian plastics in the Adriatic, or where have you found plastics from around the world? Do you track that sort of thing, Martina?
So actually, it's not part of my project on my research field because my aim is not to track plastics, but like I said, my aim is to find microplastics in the environment and to study their biological effects. What does it mean, biological effects? I want to know what microplastics are really provoking to marine life and also to possibly to humans, because like I said at the end of my presentation, my publication is just out, and we found that the cocktail of contaminants that we isolated from the surface of microplastics can have a metabolic effect. What does it mean? That all these chemicals can affect the metabolic functions of a body. So not only animals' metabolic function, but also potentially humans. So yeah.
Yeah. That's fantastic. It actually leads really nicely into our next question. I just want to note for the student that asked that, though, we have had a lot of sessions that cover plastics and where they end up around the world. Probably the coolest one, Clipperton Atoll. We did a live broadcast from the most remote island in the middle of the Pacific, and it was covered in plastic. So there's no people there, and yet it's covered in plastic. The entire beach, you go to the bottom of the ocean, it's got plastic. Antarctica has plastic. So it's a problem that really affects everyone and everyone contributes to, and there's a lot of easy solutions for which we can get to in other things later on too. To the point of affecting bodies. So in Ms. D'Andrea's class, the question from the student is, are microplastics so fatal that they can eventually lead to illness or death? So it's a dark question, but a good question on the thing that a lot of people are concerned in. Are there any indications that
This is a really, really interesting question. So first of all, for now, we don't know. You should know that microplastic research is, how can I say? So many scientists are currently studying microplastic all over the world. But the problem is that we currently don't know for sure how dangerous they are. We found really lethal effects in many marine organisms, but we don't know how lethal can be for us. Anyway, what we know is that some of the contaminants associated to microplastics can be lethal, not in a really short term, but in a really long term. So they can provide their toxic effects days per days, years per years. So basically, what I'm saying is that we can't see their effect now, but maybe we can see their effect in some years. But like I said, it is a really interesting question. But you should know that microplastic research is still at the beginning. If we are studying them since, I don't know, 20 years.
Right, which is so exciting. And we love to highlight sciences where, like, this is a really novel approach. There's a lot of new researchers, there's a lot of investment in this. So if you're interested in microplastics, this is the best time ever to be involved in it, because we're seeking all around the world to understand it and all its effects. So great question, guys. Let's go back to Ms. Ryan's class for another question. So just demute your mic and come on in, guys.
Hey, Martina. We've had some funding cuts to some of our local organizations, and last year I had a group that was supposed to come and do a water analysis with us from one of our Great Lakes. They've lost their funding, and I was just wondering, is there any type of equipment that we could use to test for plastics in our local waterways?
So maybe we can talk about that in a separate room. Yeah. But anyway, no, that's interesting. But anyway, we can, for example, the sampling tool that I just showed you in the presentation is, one of the devices that scientists use for collecting microplastics from surface seawater. So yeah, this is, for example, a really useful tool. But maybe I can leave you my email address and we can chat. Yeah,
that would be amazing. So we can set that up after the fact too. And I wanted to note for you and for any other class, so one of the groups we've had on numerous times in Southern Ontario is the University of Toronto trash team. So this is like a team of like 30 amazing educators that actually do exactly this work, and they come and they help you do stuff in streams and do outreach and education. So I can put you in touch with them, Ms. Ryan, as well. I'll remember to do that by the end of the broadcast. You can chat with Martina, can chat with them. We can chat with everybody. It's a good time.
Yeah. They are amazing. I know them. Wow.
Great question, guys. All right, Miss Devon's class, where would the most common plastics, microplastics be from? Is it plastic bottles? Where can we find, like, what produces the most microplastics?
That's a really interesting question too. So first of all, scientists found that the great part of the garbage that ends up to the ocean is made of plastics. Almost the 80% is made of plastic. So that's why when we refer to trash pollution in the sea, we refer to plastic pollution. Also, it has been estimated that the greatest part of these plastics come from single-use plastic. So we are talking about plastic bottles, plastic caps, plastic cutleries, plastic plates, but also plastic containers, like for the shampoos, for example. So yeah, what's the point? That's an interesting question, also because let me connect it to another interesting point. So what we can do for avoiding the spreading of more and more microplastic in the ocean. So we can basically start from reducing or avoiding single-use plastics objects from our life. For example, don't use plastic bottles anymore. Let's use a reusable bottle for drinking our water of our drink. Say no to plastic straws, for example. Come on, guys. We don't need a straw to heat our drink. Then let's keep in our bag, I don't know, a reusable cap, a reusable cutleries for having lunch outside. If we go shopping, please don't ask for plastic bags. We can bring with us our reusable bags. Yeah, there are many ways for avoiding the spread of single-use plastic. So yeah, it's an interesting question because we can understand how we can avoid this problem at the origin.
Yeah, it's really one of the things that I love when we talk about marine plastics and microplastics is that it's not a political issue. Like no one says, oh great, the beach is covered in plastic, how wonderful. Everyone doesn't like this. Everyone can play a role. It's a really important thing. So I'm really glad we got that message in. All right, we're going to take about 3 more questions, a couple more from YouTube and Facebook, one from Mr. Seeberger, who just joined us, and welcome in, Mr. Seeberger. So I'll come to you in a second. So Miss Hexamer's class, they want to know, can microplastics in the water end up in the ground and in plants? So we've talked about microplastics in fish and in animals. Do they get absorbed by plants as well or not? Do we know?
Yes.
Okay.
Unfortunately, it has been found also in the landfill, inland, and actually, shellfish or fish are not the only source of microplastics. You should know that microplastics can be found in many beverage, in bottled beverage. Microplastic has been found also in water, running water. Yeah, that we have in our houses, basically, has been found in the honey too, in the sea salt, in many food and drinks, but also in vegetables, so fruit and vegetables. And actually, I'm really proud that one of the first research groups that found microplastics in plants is an Italian research group. One of them is from the southern of Italy that found really tiny microplastics, in vegetables that can be captured, so internalized by the roots.
Yeah, there you go. Distressing, but very cool. Like, it's fascinating stuff. We just don't want to have to think about that, but that's why we can all make a difference together. So awesome. Let's go to Mr. Seeberger joining us in Kitchener. Mr. Seeberger, welcome in.
Hello, can you hear me?
We can hear you fine. Go for it.
All right. We're just starting our unit, of course. The school year actually just started here up in Canada on human interaction with the environment. But our question would be related to our main project that we're going to be working on. And we're going to be building a grant proposal. So our question would be, what advice would you give us on building a grant proposal for when it comes to saving endangered species or conservational efforts and all of that? And if you can share experience about getting a grant proposal.
I love it. I've never had that. We've never had that question in the history of this program. So thank you so much for that. So Martina, go for it. Take it away. I'm curious of your answer.
I don't know. I personally think that you should at first analyze, detect an area, a specific area, to detect the kind of species you want to protect, and to understand which are the factors that are threatening these species. So you can act directly on these factors. So you have to think about how to avoid a certain, I don't know, if plastic pollution, for example, is one of the threatening factors, you should work on that. Yeah, you have to find the source of this threatening. Another important, in my opinion, of course, another important aspect is the involvement of the community, the citizens. How the community can together help to protect these species or these areas, because if it is a job made only by scientists, it is a job that finish with the project. But when the community is involved, of course, it is a long-term project. So it means that the actions that you are building can remain also in the future. I don't know if I got
No, that's perfect. Well, so one of the things that in Mr. Seeberger's class, you guys will notice this if you look into other grants right now, community conservation, community involvement, what Martina mentioned, is one of the biggest things in the world right now. We found that basically if the local community isn't invested in the work that you're doing or the end game of what you're trying to accomplish, it is ultimately pretty much doomed to failure. So it's really important to link in that community. National Geographic, which Martina's been funded by, if you check out their page for grants, you get a really good sense of how their granting works. And I really encourage you to do that as well. What a cool question, guys. Martina, we're near the end of our broadcast. It goes so fast. So I wanted to give you a chance, if there's one last message you'd like to share about microplastics, about your own work, maybe where kids could learn more about you, anything you want to share to wrap us up today.
Thank you, Jess. Yeah, so like I said, you can follow me on Twitter or Instagram. I sometimes share some interesting tips. So yeah, over there you can find also my previous posts. And yeah, one last quote. Just remember that the planet will change with the action of everybody, not with the action of a really small amount of person or researcher. So everybody can do something for safeguarding our planet.
Fantastic. Can't think of a better message to wrap than that. So thank you so much for joining us today, Martina. We really appreciate you leading us off with high school presentations and marine plastics as a topic. And it's just been such a great time. So thank you so much.
Thank you. Bye.
All right.
Bye.